Hi class, today we are doing section 1.6, Equations and Inequalities using Absolute Value. Now there's a lot covered in this section, and there's a whole chapter in Math 72 covering absolute values and equations like this. If you don't have a good grasp of that, you might want to refer back to previous textbooks, or maybe refer to some of the links that I'll share with you in class. And also with the My Math Lab homework, you might want to watch some of the videos that are accompanying this section. I'm going to do sort of a quick overview. We're calling some of the really key important stuff, but it's really important that you practice each of these equations, that you do them on your own, and that you practice it before you get too far into anything else. Alright, so I just want to recall, we have a definition here. It's written on your notes pages that I've provided for you. The absolute value definition is the distance between a number and the origin, or rather the zero on the number line. So if we have an equation like number 1, it says solve the equation. It says the absolute value of x is equal to 3, meaning the distance from some number is equal to 3. Well, the distance from 0 to a number is 3. The most obvious choice is 3 itself, because this is a distance of 3. But another choice, which might not be as obvious, is negative 3, because its distance from 0 is also 3. So we actually have two numbers that can make this true. We have the absolute value of 3 is 3, and we also have the absolute value of negative 3 is also 3. And that way, we actually have two solutions for x. X can be 3, and x can be negative 3. And since we have more than one solution, we are going to write it in set notation. Alright, that leads me to our next statement here. And on your page it's written in words, if A is positive. But as you recall from a previous lecture, I said the way that we write positive in algebra is to say that a number is greater than 0. That means the same thing as positive. And we have the statement, if U is any algebraic expression, then we have two things to know. We have the absolute value of U is A, meaning that we have two equations to come from it. We have U is equal to A, or U is equal to negative A. And you actually have two statements that arise from that one statement. So if you are ever given a absolute value statement, then you have two resulting absolute value equalities that come out of it. So we have to take that into account. Notice several things about this. We have our algebraic expression in the in the absolute value that's isolated, equal to a positive number. You'd have to have both of those to be able to apply this. So here we have an absolute value equal to a positive number. Therefore, I can apply this, and I need to write two equivalent statements. Those two equivalent statements would be 3x minus 1 is equal to 2. My second statement is 3x minus 1 is equal to negative 2. Alright, then you want to solve each one of these individually. So we are going to add 1 to both sides, divide by 3, and there we got one of the solutions. I'm going to add 1 to both sides, divide by 3. Here's my second solution, and then I'm going to put both my solutions into set notation. Okay, I wrote the rules over here on the left-hand side for what we just did. I want to go over each step with you. The first thing you want to do is isolate the absolute value. That's what I did over here on the left. And make sure that it's equal to a positive value. That's what we have over here on the right. So So steps 1 and 2, you have to make sure that happens. Now if you skip over step 2, then you might get some answers that are not true. But you can always check at the very end. But it makes your life easier if you don't even do the work, if you check to make sure it's equal to a positive. When that happens, and you're going to do step 3, is set up 2 equations. So we have the 2 equations here. And I want to show that the left-hand side of these equations are all the same as the original. So all of these 3 are all the same, 3x minus 1. Don't change it at all. Don't put 3x plus 1. Don't change the signs. Don't do anything like that. Alright? But when you make your 2 equations, you're going to set them up equal to positive 2 and negative 2. This is the only one that changes signs. Right over here on the right hand side. So those are your 2 equations. Let me write them here in code. It's going to be the first equation is equal to that, and the second equation is equal to negative a. Alright, and then we're going to continue with solving, and as you solve, you can have 2 solutions and you put them in set notation. So those are the steps you're going to follow. With equation number 3, we're going to apply the rules that we have on the left-hand side. But I also want to point out that this equation can look confusing, especially if you don't have good handwriting. It's easy to confuse 2's and z's, and it's also easy to confuse those 1's and the absolute value symbol. So please make sure you're double checking your work and everything that you're doing. So first we need to do step 1. It says isolate absolute value. So we're going to move this 6 away from the absolute value. And then I need to, now that the absolute value is isolated, we need to make sure it's equal to a positive value. So that's just a visual check. Is this positive or not? Yes, it is. Great. Then I can go on to step 3, which says to write 2 separate equations. So those separate equations are going to be 1 minus 2z is equal to 3. And then the exact same thing, 1 minus 2z is equal to negative 3. And then I'm going to solve each of these individually. So I'm going to subtract 1 from both sides, get negative 2z is equal to positive 2, divide both sides by negative 2, and I get z is equal to negative 1. I'm going to do the same thing over here, and get negative 2z is equal to negative 4, so I get divide both sides by negative 2, and I get z is equal to positive 2. Now I want to check each of those into my original equation, and then I would collect them and put them here. And I'm going to leave the check up to you. For question number 4, we have an equation that has fractions in it, which we should know how already to do those. But we also have the absolute value to deal with. I want to go through steps 1 and 2. Is my absolute value isolated? Yes, it is. It's isolated on this side of the equation. Is it equal to positive value? Yes, it is. It's equal to positive 1. Great. We can continue going on. I'm going to set up my 2 equations, and I'm going to say x over 2 minus 1/3 is equal to 1. And then my other equation, exactly the same on the left-hand side, but then equal to negative 1 on the right-hand side. Once again, to get rid of a fraction, I multiply the equations by the LCD. In this equation, that means multiply by 6. So I'm going to multiply by 6 over 1, 6 over 1, and then by 6. 6 over 1, 6 over 1, and then by 6. Alright. So then I'm going to get 3x minus 2 is equal to 6. And here I get 3x minus 2 is equal to negative 6. I just like to get rid of my fractions as soon as possible. So now we can solve each of these equations. I'm going to add 2 to both sides. Get 3x is equal to 8. And then get x is equal to 8 over 3. And I'm going to leave it like that. I'm not going to try to simplify. I'm going to add 2 to both sides. I'm going to get 3x is equal to negative 4. I'm going to divide by 3 and get negative 4/3. Now, really what we should be doing at the bottom of each of these equations is checking to make sure it's valid. So please check, plug these in, see if it works. Like I said, I'm going to leave all the checks up to you. We have two solutions. Every time I have two solutions, I'm going to put them in set notation because that's the proper way to do multiple solutions. Okay, let's go ahead and do question number 5. Let's go ahead and follow the rules on the left. So we want to make sure we isolate the absolute value. We have the absolute value isolated over here, so we're done with step 1. We want to make sure that it's equal to a positive value. That's what step 2 says. Well, look at this. What is it equal to? It's not equal to a positive value. So technically at this step, you could say, you know what? There's no way that the absolute value is equal to a -1. And you could say no solution. And then you could be done. Like that, you could be done. You don't have to do any work. Now, this is my recommended steps. But I know that some of you won't recognize this. And so if you forget to do this, let me show you what it looks like. I'm going to sort of speed through this because you shouldn't be wasting your time doing this work. You should recognize at the very beginning, not valid. You can't have a negative absolute value. But let's just say that we do this. You should clue in around here that, hey, you know what? That was already negative. But let's say we forgot. All right, then we get negative v is equal to -3, so v is equal to 3. And then you get negative v is equal to -1, so v is equal to 1. And if you're tempted to say this, you really should do this step here, the check. And so let's try it. 2 minus 3 is equal to -1. So you get the absolute value of -1 is equal to -1, which is also not true because the absolute value of -1 is +1. So we'd have to throw this one out. And then we do the same thing here. 2 minus 1 is equal to -1. You get absolute value of 1 is equal to -1, which is also not true, so I'd have to throw that out. So then I would get no solution. Now, do you want to go through all those steps just to say no solution, or do you want to recognize in the very beginning that, hey, you know what? This is not going to be working for me. It doesn't work. I can say no solution and be not doing any of the math. So it's up to you. But this is a very, very important step. Step number 2, you have to make sure that your absolute value is equal to a positive value before you waste your time doing any of this work. Don't waste your time. Say it right at the beginning. No solution. I changed the rules on the left-hand side just slightly to accommodate our new topic. We are now dealing with inequalities. And so you still want to do step 1, isolate the absolute value. You still want to do step 2, make sure that it is less than a positive value. It's not going to be equal to a positive value. It's going to have an inequality symbol. But you still want to make sure that the right-hand side is still a positive value. And then you're going to set up your 2 inequalities. Now, it looks like I have 2 inequalities here, but it's not 2 different lines. It's one line has 2 inequalities in it. So I want to show you how that works. Looking at number 6, we have the absolute value of x is less than or equal to 3. That satisfies step 1, the isolated absolute value, and step 2, it's less than a positive value. Here are my 2 inequalities. I'm going to take that phrase inside the absolute value, and I'm going to put that inequality symbol on either side of that x. And I'm going to take 3 and put it on this side, and put -3 and have it on that side. And there we go. And then if there was anything else you needed to solve, you would then continue to solve. Now, let's talk about what that looks like on the number line. That's an interval. So you would have -3 on the number line. You would have 3 on the number line. You want to include these as part of our solutions because they're less than or equal to those values. And you want your x to be in between those values. So here we go. Here's our x. Now, I have a lot of solutions. I have an infinite number of solutions here in between these 2 numbers. It's on the number line and I'm shading it in. So instead of doing my answers in set notation, like I've been doing before, I'm going to put them in interval notation. So I'm going to say these numbers, including my endpoints, go from -3 to positive 3. Always when you have an interval of solutions with an infinite number, you want to put your solutions in interval notation. We no longer use set notation this way. Alright, for number 7, we have an inequality that has a little bit more steps than the last one. We're going to follow steps 1 through 5 as we solve this. So we want to isolate the absolute value. So that means moving the 3 over. I'm going to get x plus 4 is less than 2. Now we want to check that the value on the right hand side is positive. It is, and since it's positive, then we can move on to the next step. We're going to set up our two inequalities, and that is our phrase in the middle with our inequality symbol on either side. And we're going to put the 2 on the greater side and the negative 2 on the other side. And then we're going to solve this by subtracting 4 from all 3 sides. And I'm going to get negative 6 is less than x is less than negative 2. Now you want to solve and then check. So what you want to do at this point is see what you can do about take a number, plug it in, see if it works. Now you can't take it at endpoints because it will not make it true, but you should be able to check. And let's go ahead and write this on the number line. Negative 6 to negative 2. We're not going to include those as part of our solutions, but we are going to include all the numbers in between. So we're going to put that, use our set notation using parentheses. And there we go. Those are all of our solutions, an infinite amount. Let's move on to number 8. Now this question says the absolute value of 6x is less than negative 2. We're looking at this and it follows step 1. The absolute value is isolated. But looking at step 2, it is not less than a positive value. It has a negative value right over here. So we can't do it. Technically, our answer is no solution. But I want to take a little bit of time to explain why this is true. If you're looking at the number line, the 0 separates the positives from the negatives. And when we look at the positives and the negatives, you have negative 2 is over here. Now what we're saying is somehow the absolute value of 6x must be less than negative 2, but that's not possible because the absolute value of 6x should always be positive. So we should be having numbers on this side of the equation, but we actually have this here. It's not possible, so we're going to throw it out. I'm going to use this illustration to do a couple other questions that aren't on our note pages. So now let's just do a couple of equations. We want to say the absolute value of x plus 5 is less than 0. I want to remind you, what does this mean? Less than 0 means negative. So basically, this statement here says the absolute value is negative. When can my absolute value be negative? Never. So I won't have a solution for that. But let's take into account what happens if I have it less than or equal to. X plus 3 is less than or equal to 0. What does this mean? It means negative and 0. So let me write that down. Negative and 0. So when I have something like this, can my absolute value be negative? No, it cannot. Can my absolute value be 0? Yes, it can. So I'm going to say x plus 3 can be equal to 0. So x can be equal to negative 3. And here I would have only one solution. And this is somewhat confusing. It really just depends on what your symbol is and what that symbol means. So let's go over the 3 questions on the page right now. If you have an absolute value less than a negative, you can't be less than a negative because that means negative also. So we have to say no solution. If I have an absolute value less than 0, I also cannot be less than 0 because that also means negative. So then there's no solution there. But if I say negative and 0, I want to throw out that negative, but I want to keep the 0. Right? That's two separate statements. The absolute value is less than 0 and the absolute value is equal to 0. And I'm going to keep the portion that was equal to 0 because that one can be true. And then I solve for that one solution. I updated the rules on the left-hand side of this page, and it's on your note paper, but the only words I updated were the words greater than, and also the two equations that I have over here, or I'm sorry, the two inequalities. And so we're going to be practicing greater than inequalities. Now, when we work on this equation, you want to make sure this inequality, you want to make sure you follow steps 1 through 5. Step 1 says isolate the absolute value. It is isolated. Step 2 says make sure it's greater than a positive value. It is. And so we're going to make our two inequalities. Now this one actually makes two inequalities. The first one is 3x plus 4, and we're going to go ahead and switch the symbol and switch the sign. And then the other one says or, and then we're going to write this the way it looks, keeping the symbol and the sign. Subtracting 4 from both sides, we get 3x is less than or equal to negative 6, so x is less than or equal to negative 2. Adding or subtracting 4 from both sides here, we get 3x is greater than or equal to negative 2, so you get x is greater than or equal to negative 2/3. Now let's just look at what that looks like on a number line. You have negative 2 and negative 2/3. It's greater than or equal to, so we're going to include those, but x is less than negative 2 goes to this direction, and x is greater than negative 2/3 goes to this direction. So we actually have two intervals, and so those two intervals are going to be negative infinity to negative 2, including the negative 2, and also all the solutions into negative 2/3 all the way going to positive infinity. So we have two solution sets, or two intervals that our solutions are sitting in. You want to make sure that you include both of them. Always, they might not ask you to do the number line, but if you draw the number line, it gives you a good idea on the fact that you have two intervals and that you need two interval notation solutions. Practicing this concept one more time and with fractions, we have number 10. The absolute value of 5 minus 2x all over 9 is greater than 8. So this uses the rules on the left-hand side. We do have the greater than, so we're going to set up two separate inequalities. That's going to be 5 minus 2x over 9 is less than negative 8. And we also have 5 minus 2x over 9 is greater than 8. Solving this, every time we have a fraction, we ask what is the LCD? In this case, there's only one denominator, so that's going to be 9. We're going to multiply both sides by 9. And I'm going to get 5 minus 2x is less than negative 72. Notice I didn't multiply out because those 9's cancel out. I'm going to subtract 5 from both sides. And then I'm going to divide by negative 2. What happens when I divide by negative? Well, the symbol switches direction. So that's my first part. Let's do this again. We're going to multiply by 9. So I'm going to get 5 minus 2x is greater than 72. I'm going to subtract 5 from both sides. And then I'm going to divide by negative 2. Once again, what happens when I divide by negative 2? That symbol switches directions. And there we go. Let's put these on the number line. Now 77 over 2 is positive, and negative 67 over 2 is negative. So in this order they go. And we're going to have less than and not equal to, and greater than and not equal to. So what does this look like as a solution set? Well, we actually don't use a set notation, we use the interval notation. I'm going to say negative infinity to negative 67 over 2, parentheses, union, parentheses, 77 over 2 to positive infinity. And there's our solution. Question 11 says, the absolute value of 3x is greater than or equal to 0. Now looking at our rules, our absolute value is indeed isolated. However, when it says greater than a positive value, 0 is not a positive value. 0 is 0. And so when we say something like this, what you're actually saying is my absolute value on the left-hand side positive, or 0 on the right-hand side, right? Because anytime I have greater than 0 or greater than or equal to 0, we have this statement. Is my absolute value positive? Well, yes. When is it positive? All the time. When is it 0? All the time. Well, not all the time, but we have it's either positive or 0 all the time. Our absolute values can never be negative, but they can be positive and they can be 0. So when can this be positive or 0? Pretty much all the time. And so when we're thinking about the number line, any number you plug in is going to work. And we just say all real numbers are solutions. Alright? In interval notation, that would be from negative infinity to positive infinity. We have all those numbers as our solutions. I just want to bring up an extra example that's not on your note page. If I said the absolute value of negative 2x plus 5 is greater than negative 7. Once again, let's write in words what this says. Is my absolute value greater than a negative value? It actually doesn't even matter what numbers we have plugged in here, but is my absolute value greater than a negative? Well, if my absolute value is always positive or 0, is that going to be greater than a negative? It sure is, right? And so this is going to be the same thing where any number I plug in is going to be greater than a negative. So you're also going to have all real numbers as your solution. And so we have these special cases where this happens, and you just have to keep in the back of your head when you're dealing with absolute values, the absolute values are always going to be positive are either going to be positive or 0. And if we can remember that rule, then that makes some of these questions very easy, because you ask yourself, is this positive number greater than a negative? All the time. Is this positive number less than a negative? Never. Right? And so we can have those special cases that the rules aren't set on the side, but we do have those special cases, and we have to keep this rule in mind. The absolute values are always positive or 0. All right. Then that's section 1.6.